Sun is almost 5 into 10 raised to 6 Kelvin hot, and its main components are hydrogen and helium. But how do we know that Sun is this much hot and what the Sun is made up of? In order to understand the composition or the temperature of Sun or any other uh, stars that we see in the sky, we need some mechanisms. So if you want to measure the temperature of Sun, how do we measure it? Uh, can we take a thermometer and place it on a spaceship and send it to the Sun and take some uh, samples and analyze it to understand the temperature or its composition, or it's, as we all know, that is not a feasible way. So if we can't go to the Sun, then Sun should come to us. So in the nature of the amount of light or the heat that is coming out of Sun, it reaches us. So we can understand about the nature of Sun by analyzing the amount of light or heat that is coming out of the Sun. And Sun emits a large range of frequencies, ranging from gamma rays to radio waves. And as we all know, as the frequencies of these waves are different, their energies, corresponding energies, will also be different. So now let's try to understand about the source of these frequencies. Different frequencies will be emitted by different kinds of molecules or atoms that are present inside the Sun. And if we have information about the different kind of rays that are coming out of Sun, we can have information about the kind of molecule that is present inside the Sun that are responsible for the emission of these rays. Now, by using this logic, we can have information about the kind of molecules or molecular interactions or atomic interactions that is present inside the Sun. So by understanding the spectra of radiations that are coming out of Sun, we can analyze its temperature, its properties, its composition, etc. Now the image you see, all those images are images of Sun, pictured through cameras that are sensitive to X-rays, gamma rays, UV rays. And as you can see, Sun have those radiations, or Sun emits those radiations in all these frequencies: X-ray, gamma ray, and radio waves. All those frequencies are emitted by Sun. So by analyzing the nature of these frequencies and reworking on the if and all there is some frequencies, there should be a source for it, and that source must be some atomic transition or atomic energy level transitions or molecular energy level transitions, or the changes in spins in the materials or the components that are present inside the Sun. So all these information can be deducted from analyzing the spectrum of radiations that are coming out of Sun. So in spectroscopy, we are using this technique of understanding or studying the electromagnetic spectrum that is coming out of some substance, and try to understand the presence or absence of some compounds, or its molecular structure or its atomic structure. And our discussion is not limited to the properties of Sun only. The entire range of astronomy and cosmology is dependent on the experimental evidences that we obtain using spectroscopic techniques, and we are analyzing the entire range of universe using the spectroscopy techniques, using spectra of the distant heavenly objects, um, ranging from radio waves to gamma rays. Again, coming back to the Sun's case, while analyzing the spectra of sun in visible range, we were able to see some dark lines, or in those frequencies the spectra was absent. Okay, so now we are trying to understand why those black lines, as you can see in this figure, exist. So these lines corresponds to some absorption that happened in the spectrum. So some frequencies were absorbed by some compounds that are present in sun, and only the rest of the frequencies were allowed to come to us. So again, those frequencies that are absent in the spectrum gives us information about some compounds that are present inside the sun, uh, who absorb these radiations. So again, um, these absorptions in the spectrum gives information about the composition of a different kind of materials within the sun. And we have a large range of spectroscopic techniques. First one is atomic spectroscopy, in which we are considering about the electronic energy levels and the transitions between different energy levels, and the resulting rays, uh, or waves, resulting waves coming out of those transitions, and we are analyzing those transitions to understand about the nature of spins, or angular momentum, or orbital properties of different atoms. And in molecular spectroscopy, as we know, molecules are made up of bonds, and about those bonds, these molecules will have some vibrations or some rotations, and these vibrations or rotations will have some energy levels associated with it. And while understanding the transition between these rotational or vibrational energy levels, there will be emission of some radiations. And if you are analyzing this, those radiations coming out of these vibrational or rotational energy levels, or vibrations or rotations, we can analyze the kind of molecule or the kind of bond, uh, and the nature of that bond present inside the molecule. And in third case, we have spin resonance spectroscopy. For we have electron spin resonance, and nuclear spin resonance spectroscopy. It is based on the spin resonance nature of different nucleons or electrons. And in our discussion, we will be dealing with atomic spectroscopy. So atomic spectroscopy have a lot of daily life applications, like in food research, or in mining technologies, in which we need to analyze the kind of atoms, or the presence of some elements in, say, we have some packaged food to analyze. So we need to understand that that food material is made commercially. So we need to understand whether we have some toxic metals or some heavy metals present inside that material. So in food quality research, basically we try to analyze these food under some atomic spectroscope, and we take the atomic spectroscopy of this material, and by analyzing the kind of peaks, or the kind of peaks that are present inside the spectroscope, and comparing it with the peaks corresponding to the atomic spectrum of toxic metals, we will be and comparing these two spectrums, we will be able to see if we have the similar kind of peaks, we can know that some kind of toxic material are present inside the material under study. So we will have an in-depth discussion about the atomic spectroscopy techniques in our coming discussions. Thank you.